All right, so picking up kind of where we left off, we're going to do this final test for logistic regression. That's similar to the nested F-test in that we're seeing if some, or at least our null hypothesis is going to have some, but not all of the beta coefficients in it. And so why might this be useful? Well, just like how it was useful for multiple regression, this is what we would have to do if we want to know if shot type is associated with whether or not a shot goes into the goal after accounting for the effects of distance. And so to do so, we're going to end up looking at the difference in the residual deviances from a full model with both shot type and distance and a reduced model with distance only. So let's go ahead and see how that's all going to play out. And so our null hypothesis for this test, it's only going to be slightly different to what we did in the last video. Now instead of testing all the beta coefficients, I'm just interested in the ones that are in front of a shot type indicator variable. And so that's just beta 2 through beta 7. Our null model in logit form, so this was like the nice kind of linear form where we have the logit of our probability of a shot going into the goal. Under the null hypothesis, that's just going to include distance. Our alternative hypothesis in words is that shot type is associated with whether or not a shot goes into the goal. And that's, of course, after accounting for the effects of distance. All right, so I'm hoping that, if we kind of like got what was going on before with the nested F-test, this should feel like not super difficult because it's not that different at all. And so that's really pretty nice, is that kind of what we're learning before is very applicable to stuff in logistic regression as well. And so our test statistic, we're still going to call G, and this time it's going to be the reduced model deviance minus the full model deviance. And so the reduced model in this case would just be a model with distance only. The full model is the model with both distance and shot type. So let's go ahead and grab both of those residual deviances. So to do that, we've already actually fit both the models that are necessary to do that. And so I'm back on page 1. When we fit this model at the very beginning with just distance, that residual deviance is 1762. And so that's the reduced model residual deviance. And then I'm jumping now to page 4 where we fit the model with distance and shot type. That residual deviance is 1756. So G in this case is 6. Degrees of freedom are the number of parameters in the null hypothesis. So in this case, our degrees of freedom are 6. And like, what? That's so weird. So that's just a coincidence. So it's not like the degrees of freedom really have any relation to G necessarily. So it's just a coincidence that in this example, they're exactly the same. And so again, if the null hypothesis is true, G is still going to follow a chi-square distribution, and so we could still use a similar type of R code to get our p-value for this test. In this case, our p-value is large, and so we're finding for this example that there's actually no evidence that shot type is associated with whether or not a shot goes into the goal. Ooh, talking is hard. So no evidence that shot type is associated with whether or not a shot goes into the goal after accounting for the effects of distance. And so our G is 6, and then our p-value is 0.4232. And so we're finding that there's no evidence that shot type is associated with this shot going into the goal after accounting for distance, but we might think that there's a possibility that the association between distance and whether or not a shot goes into the goal, that might depend on the shot type. And so if this language sounds familiar, it definitely is. This is hinting at we might want to include an interaction term in our model. In R, you could include this interaction term using the same exact type of code. And so that's something that you'll explore doing in the your turn section. And so there's kind of a cool graph that you'll make and see if there's evidence for this interaction between shot type and distance, in which case we would say that the association of distance and whether or not the shot goes into the goal, that's going to depend on what the shot type actually is. And so we could say yay, because now we all understand interactions even though they're kind of confusing, especially from the beginning. So woohoo. All right, so that's about it for this. Videos are pretty short, so you can spend the majority of your time today working on the RStudio section.